Hey there everybody. So I wanted to do a video about like a maze type toy and also show you how you can chop something open and show the inside of it, because that's a question I get a lot. So I just wanted to help some people out with that. So if we were going to do a maze type toy, what I would want to start with, of course, would be a general outline of that, and I'm just kind of sketching some ideas, but I'm going to show some more details as time goes on here. So I would start with a general outline, and I'm just going to keep it simple for the sake of this example. I'm going to show here, let me just adjust the size of some things. Let's make this a small eraser. There we go. Oh, that's not small at all. Hello. Super small. Yeah, there we go. That's more what I'm looking for. So I drew the outline of the maze, and now I am just drawing the inside walls of it. So those are going to look something like this. Let's get those a little darker there. And so that's kind of the general outline of it, because we need to know that those walls have thickness. Be careful that you're not just drawing lines and pretending that they are something that has thickness. You need to show how thick something is if you're going to draw it. So then if we were going to have on this just some simple maze-like shape, maybe something like this, and then we'll go over here like a labyrinth type shape. Maybe there's an opening like that, and then there's another opening over here. Oh, I'm getting ahead of myself. So see, I just drew a line, but I need to make sure I show that that line has thickness. Now, it doesn't have to be perfect every single time, and it also doesn't have to be super consistent, but you're going to get a general shape looking something like that. Now, I'm going to just pause my video and I'm going to finish this so you don't have to watch me do that. So it's going to skip ahead a little bit. All right, so I went ahead and I kind of finished this out. So the idea would be that the maze toy, here the ball would be in here somewhere. It's going to roll around. You'd have to go and you'd have to get it into the center part, let's say. And so that's the general idea. Now, some things to think about. Up until now, I have not assigned any sizes to this because I'm just thinking in terms of relative size. But when the time comes to actually assign some size to this, you got to start thinking about other factors, like how big is the little ball that's going to go inside of this? How big does that need to be? Because if this is how big it is relative to that, then looking at this even the way I drew it now, this is going to be an issue because that ball is bigger than these openings over here. So that's something that we need to consider is, how big are the things that are going to be inside of this. So I am going to tell you all, for the sake of, this class and everything, the balls that we will use, the diameter or like the distance across these is 5 millimeters. So that's how big these things are going to be. So if you are someone who's designing something that's going to use these little metal BBs, okay, you have to make sure that your openings here, like so from here to here, that is at least 5 millimeters, maybe even a tiny bit bigger, but 5 millimeters it should fit, because I think these are actually secretly 4.5 millimeters, so they're slightly smaller, so they'll fit into a 5 millimeter opening. And you don't have to put dimensions on everything. You can just say all paths are 5 millimeters. Okay? Now, if you think about it, if all the paths are 5 millimeters, we also need to know how thick are these walls. So let's just say, because it's easy, let's say the walls are going to be 3 millimeters. So all walls, 3 millimeters thick. And now that actually kind of makes it easier for us to figure out the overall size of this, because if we have 1, 2, 3, 4, and let's say the middle is 5 millimeters also. So 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 5 millimeter openings. So 9 times 5, or 5 times 9, 5 times 9, so that equals 45 millimeters. So that's just the spaces. And then how many walls do we have? Well, this would be 3. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I hope I counted right. So 10 times 3 millimeters is going to come out to 30 millimeters. So our total distance across this whole thing, either this way, or I'm going to just write it down here because I already have something on each side, is 45 plus 30. So that's going to come out to 75 millimeters for the total distance across here. So you can kind of work from one thing up to another thing. So I worked from the size of the ball to get the opening of the space. I picked just a good number. This is a good number that anyone could use for thickness of walls. It usually isn't going to break. And that lets me pretty quickly figure out all of the different sizes that I need. Now, the only other thing I haven't done yet here is I haven't shown how like tall all the walls for this maze are. So to do that, I'm just going to grab here a different color because I have the option to do it. What we want to do is we want to draw this as if it's sitting on a table. Okay, so I'm actually, let's flip back to this color, black. So if our table is going to be down here, I'm going to draw it sitting on the table. Well, I want to draw it the exact same width as what I got up here. So actually, you know what? We don't even need another color. I'm just going to tell you, you want this edge of the side of the maze when it's sitting on a table to line up with the edge from up there. You want this edge to line up with the edge from up there. And again, just kind of draw it proportionally right. If this distance was about 5 millimeters, so our BB would fit in here, then we don't want to make this maze super tall, right? That would be silly. If we made it super tall like that, that would be no good. So that's not what we're trying to do. We want to keep it about proportional, so if we put that little metal BB next to it, it's going to be about the right height. So, and then we can figure out, well, the maze should be at least 5 millimeters tall. It looks like I drew it maybe 10 millimeters tall, so let's just stick that in there, 10 millimeters. And later on when you're working in on shape, you might be like, all right, well, 10 millimeters is too tall, I need to make it 7 millimeters, and that's okay. And so this would be a view of it sitting on the table. But the other thing is we need to see like how thick is the bottom of this, you know, because, and it's good that I did this 10 millimeters because if we just had it 5 millimeters and we didn't have room for like a floor inside of that, which we could show the floor with dotted lines like this, and maybe the inside edges with dotted lines, those are called hidden lines. Hidden lines. Okay, those are the dashed lines. They're like X-ray vision, like we're seeing the inside of it. If we had this exactly 5 millimeters, we wouldn't have room for a floor, or the ball would be sticking out the top. So we need it to be a little taller so our ball can sit on the inside of that and we still have a floor. The floor, we could probably steal the 3 millimeters from up here because the floor could probably be that same thickness. And there's this rule that says you should never ever dimension. You should never do these dimension lines if you're doing it to a hidden line. So what we should do is we should pretend we're slicing this open a little bit. Right there, that's like we're chopping away the material. And then we can make these lines solid. And we can actually put like saw marks because it's like we chopped it open, like we took a chunk out of this maybe up there. You don't need to put that mark up there. You can just do it down here. Now we can say the distance from here to the bottom, and I'm going to actually get rid of the table line now. So we could say the distance from here to here is 3 millimeters. 3 millimeters. And now you've shown me everything that that we need to know. You've shown me how big it is overall, and maybe if we said like all sides, because we didn't put a dimension from here to here, we're just going to skip that. So you're telling me it's a square. It's 75 millimeters from here to here. The openings of all the paths are 5 millimeters. The distance, the thickness of all the walls is 3 millimeters. The size of the ball is 5 millimeters. And you figured all the stuff out. You have to just pick one thing and work off of that. And that's going to be the best way to get from kind of point A to point B. And you know, the only other thing I forgot is we really need a piece of like clear plastic on top of this. So let me get that in there. So some clear plastic, and you can even label this. Let's extend our chop mark up there. And let's put the saw marks on this going a different way. So you could call this, you could say clear plastic. And then you could even label the bottom part and say 3D printed plastic. And that would be a great way to show how you're going to do a maze toy. So I hope this helps some people, and I hope this is clear. And I'm sorry it went on so long, but I hope it helps you. So let me know if you have questions, people.